Welcome back to our channel, that is AI Next Generation. So this is the continuous video of the last 4 video we have just done that's related to the chest X-ray detection. So we already in the previous video we already been the model, that is a ANN model. Now we want to train that particular model. Okay, so we will just do with the first of all, for the training, what we are just going to do, we have to just first define the loss function, which loss function we are going to use. Okay, so we are just training our model, we are just writing one function that is a training function for this particular COVID-19 chest X-ray detection. Okay, so first of all you have to say which loss function we are going to use. So we already has been discussed, if you are using a cross entropy loss. Okay, so you don't have to write softmax activation function in the output layer, because by default cost entropy loss they implement softmax first, then after hands-on go to the cross entropy loss. Okay, so what you are just going to do, you have to just say from where nn dot cross entropy loss. Okay, you have to write this entropy loss. Okay, you have to call this particular, let's see. Okay, and then after that you have to say which particular optimizer you are going to use. Okay, so which particular optimizer you are going to use, it's depends upon I think INTRO, sorry for spelling. Okay, so which particular optimizer you are going to use for this. Okay, so you have to just say about the optimizer. We already have been imported optim. From that particular optim we are just importing, either you can use stochastic gradient descent or Adam optimizer. Okay, it's up to you. So we are sticking to the stochastic gradient descent, and here it takes two parameter. One is the model dot parameter, okay, the weights of the all parameter, training parameter, and the second thing is take the learning rate. Okay, so which particular learning rate you want to give. So we are just keeping like 0 point, we are just keeping 001. Okay, cool. So you are done with the initializing of the loss on optimizer, which particular you are going to use. Now you will just create one method, one function, that is a training function. Okay, for training the method. Okay, for training the COVID-19 chest X-ray dataset. Okay, so train method you are just creating train function, and it can take two parameter. You can just pass which particular model you want to pass. Okay, you can even pass model, and then after you can just pass loss function you are just going to take, and the optimizer. Okay, clear to you? I don't think so you will have doubt in this. So inside that you said how many epochs you want to train. We are just going for the only 15, and then after just create an empty list for the training loss, testing loss, validation loss, and validation accuracy. Why are we are just creating this thing? So whenever you want to visualize this thing in the graph, okay, you want to see something how your accuracy curve is increasing, and after every epoch, and how the loss function is decreasing and loss is decreasing after every epoch. Okay, training loss, or whether it is a validation loss. Okay, we will see this thing. So what you are going to write here, training loss, I'm just writing here, you are just creating the empty list, then after training accuracy, creating then empty list, and then after you are just creating validation loss, creating the empty list, and then after you are just creating the validation accuracy. Okay, so I don't think so you will have doubt in this. You are just creating only the 4 list. Okay, so you whenever you will just run for the every epoch, you will append this thing, what value you are just getting after every epoch, the accuracy and the loss of that. Okay, so now you will just move through the all the epochs, the epoch in range of that particular epochs. Okay, you have just defined total epochs as a 15. Okay, now you want to do, before that you have to say, you have to initialize the two things, train loss equal to 0.0 and train accuracy. What does it mean? So you are just initializing from 0, because after every iteration you will add up this accuracy, so that how many iteration means how many batch size it go on to the forward and backward, then after the sum of that and divided by total number of data set, length of data set, that you will get the accuracy. And similar for the loss. Okay, you will see this thing in the detail, don't worry for that. So now you will say to the model, we are in the training phase. Okay, you just write model dot train, and then after you are just going to say from image comma labels. So image, you can just even pass images comma labels in basically the train loader. Okay, so we already have defined the train loader, and this you are just iterating, you are just going through the, you are just taking that the 32 batch size. I think we have taken 16 batch size. Let me see. Yeah, it's we have taken 16 batch size. Okay, so the first 16 image will go for the forward propagation, and during back propagation it will just update the weight for the only for the 16 image. Okay, then again it will take the 16 image and it will go on. Okay, so what you want to say? So here you will say, first of all you will say optimizer. Okay, so optimizer dot zero grade. Why I'm just doing so, every time you want to do the iteration for every batch size, it will be the different iteration, because you don't want to take the previous gradient. Okay, you want to substitute, you want to restart with the zero grade. Okay, for the every batches. Okay, so then after that what you have to do, you have to pass to the output layer. Means you will get some output after passing to the model, and you will pass the images. Okay, so you will get some outputs. Okay, images, because you now you will match with the loss function. Okay, the loss function we are going to use, that is a cross entropy loss. Then you just round here loss function, and here just pass the particular which you have to just pass output, what you are just getting from the model output, and then after what is the actual, you will match with the labels. Okay, you have the label that is the actual, and output that is predicted by the our model. Okay, so I don't think so you will have doubt in this. And then after what you will say, you want to back propagate. Okay, so backward, what does it mean? It will only calculate the gradient. Okay, that's it, calculate the gradient. Okay, and similar if you are going for the optimizer GK, it is resetting the gradient. Okay, reset the gradient. Okay, yeah, I don't think so you will have doubt in this. And then after that what you are just going optimizer dot step. What does it mean? Now you are just applying the formula, that you are just updating the weights during the backward propagation. That is a w new, you are just writing w new equal to w old minus learning rate into gradient. Okay, grade you are just writing. So in the loss dot backward, you are just calculating the grade, and then after you are just applying for that all the particular parameter, that is the training parameter or training weights. Okay, you are just changing the weights of that during the back propagation. Now what you are going to see, now you will match with the prediction. So what do you mean by prediction? Means how much, what prediction has been predicted by our model. Okay, so for that you are just going to do torch.argmax. Okay, so torch.argmax, here it will take two parameter. So one is the output, so from there you want what torch.argmax will return. It will just return the index of which particular, see in the output layer you have three neurons. Okay, so which particular neuron will have the highest value, that will be our prediction by the model, because the more the value in the neurons, or the more the probability in the neurons, means that is our output. So you are just taking your, with the help of torch.argmax, you are going through the output. Okay, all the three value you are getting, and then from that you are just returning the index of that particular neurons. Okay, with the help of prediction, so that you will match with the actual. And index, basically you already know that image folder already have been done index of 0 1 2, and similar you will get the return of that. Okay, so that you will see the accuracy of that. So how you are going to see the accuracy? See, they already you have been initialized train accuracy. So what you are going to write, train accuracy equal to prediction, what model has been predicted, and if it is actual to the labels. Okay, you have the labels. Okay, then if it is, then you are just going to do the sum, and from that sum you want only the items from that. Okay, item, clear? I don't think so you have doubt in this. It is really easy. And similar for the loss also, train loss, you are just iterating, and you are just loss dot item. Okay, yeah, so now you are just appending, you are just going for the every iteration. Okay, so that you are getting some sum after every iteration. So you want to see after one epoch how much accuracy you are getting and how much loss you are just getting. Okay, it's clear to you? I think so you will no doubt in this. And then after that what you are doing, okay, but you have, after that you have the training accuracy and training loss. Okay, for that what you can just do, let me explain. Training accuracy dot append, you already have been initialized with the empty list. Okay, so you are just appending this training accuracy. Okay, so train accuracy you will get after every epoch, because this loop will run up to how many batch size you are just passing. Okay, it can be how many iteration it is running. After that you are getting some accuracy. Okay, now you are just appending this particular accuracy for the one epoch, the train accuracy divided by total length of data set. Okay, so total length of data set is the what you have this have been this pass. Okay, I think where we have just trained data, I think we have just mentioned, yeah, trained data, this is the length of data set, that is 251. So you will just divide with the length of 251. Okay, train data. Similar you can just go for the loss. Okay, testing, oh sorry, I'm not going, training loss dot append, and you're just writing train loss their loss divided by length of what you will just write. You will write the length of train loader. Why I'm just going to write of length of train loader? Because whenever you are just calculating the loss, here you are just getting the loss. It's already had been divided by the total number of. Suppose you have total 16 image. Okay, so already it has been calculated total 16 images. Okay, so like you are just getting for the one image something 0.2 loss, something 3.3 loss, something. Okay, so sum of all divided by 16, it is already done in the loss. Okay, so that's why you are not taking the particular whole training data. You are just only taking the batch total number of iteration, how many iteration it has been done, this one iteration. Okay, how many time the loop has been run. Okay, this is done with the training. The similar, now you are going for the testing purpose. Okay, what do you mean by this? So we will use with the torch, means you are going for the validation of the data. Okay, so in that particular you will not update any weights, but the rest what I have just done, it will be the remain as it is same. Okay, you are just writing grade, and then after that what you are going to do with torch.noGrid, and then you have to iterate through all the image comma labels in particular you have in the well loader. Okay, well loader, and it is the same what we have done. You will just take the output, but before this you have to initialize. Okay, we have to initialize with the test loader, that is the test loss equal to 0.0, and not a test loss, you can just say the well loss. Okay, well loss, and then after you are going to say well accuracy. Okay, 0.0. Okay, so for image comma later, and similar way you have to just pass with the output. Okay, what you are just getting the output from this particular model, you are just passing the well data, because in this particular with torch.noGrid means you don't want any gradient, you don't want to change any weight, you want to see after every epoch how your model is performing on the validation data set. That's it. Okay, so here you will just pass here images, and then after that what you are going to do, you want to see the loss of that. You already have the loss function, then you will pass the output, and then after from output comma labels for that. Okay, clear with this? Okay, I don't think so you will have doubt in this. And similar way you have to see it for the prediction. As it is, you have to just do prediction. Already we have done in the training also. You have to write the torch.argmax. Okay, it will just argmax will return you the maximum value of that particular index. Okay, it will return the index of that particular which has the maximum number of value in that particular neurons. Okay, so here you will pass the output comma 1. Clear? And then after that, after the prediction, what you are going to see, you are going to see the test accuracy and test loss. Okay, not a test, every time I'm speaking the test accuracy. Okay, well accuracy plus equal to what you are just going to say, if prediction, if your prediction, okay, if your what the model has been prediction equal to labels, then do the sum what we have done for the training, it's same as it is. Okay, sort item, that's it. Clear? And then after that what you are going to see, and similar for the loss, well loss you are just saying plus equal to loss dot item, that's you want. Clear? You are done with the well also. Now you want to append this thing into testing accuracy and testing loss, what you have done there. Okay, for that what you are just doing similar way, that not a testing, we have done validation loss, and validation accuracy. Okay, validation. Okay, so we are just writing validation loss, that you have to just do the same as it is dot append, and here what you have to append, just well loss you already have been done this, and divide by the length of, okay, the length of well loader. Clear? So I don't think so you will have doubt in this. And similar way for the particular validation accuracy also. Okay, dot append, and you want to append the well accuracy divided by length of total well I think well data. Okay, yeah, so you are just getting the loss, you are just getting the accuracy, and you are just appending this thing into a empty list so that you will able to visualize this thing. Okay, now the last part is only things is left, that is the only you will just write, you are going for the printing purpose. Okay, you want to print this thing. So how you are going to print, you are just writing print something, that's the first of all you want to see for the epochs, and you are just writing placeholder for that, and then after that you are just writing training accuracy and you're just writing we want only 0.2f floating value, that's it, we don't want more than this. And similar way for the training loss we are seeing, and similar way you're just writing 0.2f. okay, and similar way you can do for the validation loss, validation accuracy. okay, validation accuracy, and you're just seeing 0.2f, and similar way we have to do for the validation loss. okay, loss, and you're just writing the placeholder for that, and you're just creating 2f. okay, clear with this? Now you are just writing format. okay, this is the way we are just going to write. Then epoch, we already have epoch, start with the 0, you have to just add +1. Then after you already now you are going for the training accuracy. For what will be the training accuracy? So train accuracy divide by what we have done the similar way, this one. okay, you can even copy this one, train accuracy. Why it's copying all this? You can just do the copy of this, that's it, train accuracy, this one, done with this. And then after that you are going to say about the similar way for the particular, the thing is the training loss. okay, so training loss you already has been done, train loss dot divide by length of train node. okay, the same as it is, you have to just copy and you have to just paste here. okay, similar way we have to do for the validation accuracy and validation loss. So validation accuracy is this, and you have done, so they are really easy, so even you can just do, no need to explain about this. And again for the val accuracy, val loss also you are clear with this. okay, clear, done. Your you have done with this, and I don't think so you have to do afterwards anything. okay, but the thing is that what you have just appended this particular training loss, training accuracy, validation loss and validation accuracy. okay, so how you are going to do this thing? okay, because you need this thing to for whenever you go for the training purpose and testing purpose, you want to see this thing in the graph. okay, so how you are just going to see, you can just plot this thing below only. okay, so yeah, you can just write here, after printing you want to plot plt dot plot. The first plot we are going to plot between the accuracy. okay, so first plot, you just give the title first, plt dot title, and here we want to just give the title between the accuracy, you want to plot between the accuracy versus epochs always, because it can be training accuracy and all validation accuracy. okay, then after you are just writing plt dot plot, and here you have to just give the particular range basically the epochs total you have just passed, that will be in the axis. you have to pass the 2, that is the x, and the y will be basically our training accuracy. okay, this will be training accuracy. okay, we already has been initialized this thing, this one, training accuracy. okay, and then after that you have to just give the label of that, what is this? okay, training accuracy. okay, clear? I don't think so you will have doubt in this. Similar, you are just plotting for the particular it's the same as it is of the validation accuracy. okay, so you want to see how after every epoch training and validation accuracy is increasing. okay, this is the x, and then after you're just passing the validation accuracy. okay, and then after you're just giving the label, so and then after you are just giving validation accuracy. okay, see, you can just keep the same as it is. Now what you have to just do, you have to just say plt dot legend. okay, legend is basically that you are just going for the this label. okay, you have to display this thing in label. okay, legend, and you have to just initializing this thing, and then after you have to just say what is the plt dot x title, and you are just giving x title or x label, you can just say. okay, so in the x label you are giving the basically your x label is basically your epochs. okay, and your y label is basically a y label is basically your basically you will be your accuracy. okay, it can be training or testing accuracy. okay, validation accuracy, we can just write here training or validation accuracy. okay, now you have to just write plt dot show, that's it. I think you have done with this. The similar way you have to do for the particular, what we have to do, similar way we have to do for the particular loss also. Okay, so you have to just write here loss. I'm just copying pasting loss, and here you have to write the lost accuracy. Training accuracy, that means lost accuracy, not a training accuracy, training loss, validation loss. Okay, you have to change that it is, and here also you have to just write training loss, and here you have to just write here validation loss, and here you don't have to say anything, and here you have to say training validation loss. Okay, clear? So I don't think so you have doubt in this. Just check the spelling, it may be somewhere mistake. Okay, so yeah, it's really working fine, and what you have to do, everything is right correct, and just run this particular function. And before that you have to just say reset the gradient. Yeah, I have just given the dot. Why I have just given the dot for that? It's where, it's here. Okay, you don't have to give the dot. Okay, so it's now what you have to, call this particular function, that is a train method. Okay, you have to just pass train model, and the rest you have just pass the loss function, and again the third thing you have to pass the optimizer for that. Okay, here just run. Okay, let me see if it is running or not. Okay, so if we have just taken total 15 epochs, so for the 15 epoch it will just take some times to run. Okay, so again, if in the next video I will just show you how we have just done this particular training function. Okay, don't worry for that. So it was really easy for you understanding. You are just creating one function, that is a training function, and you are just creating inside that the two things. One is the train loader, the training, and one is the val loader. Okay, validation. In the training loader you are just seeing after every epoch you are just changing the weights during the back propagation. Okay, and during the, and for the particular and for the particular validation lot, you are, what you are just going to see, you are only just seeing this particular. But the thing is that it can be the thing you can just do the print before. Okay, why I'm just doing this thing before? Because you want to print this thing, that's it. Yeah, because you, after every epoch it can't be. Okay, so what you can just do, you can just restart and run all. Okay, it will not give you any error. So in the next video I will show you how to do it in, you will take the real world image. Okay, and the real world image, that is the, already we have the test data. In that you will use the this model, you already had been trained this model. Now you will see this particular model for the particular testing purpose. Okay, so you will see how your accuracy is increasing after every epoch. Okay, so the thing you are going to see. Okay, so let me do first. So if it is training, then we will continue with the next video. So it may be not any doubts for you. Okay, we have done. Now it's for the training period. Okay, so now this thing, this part, it will take time, at least it will take time more than 10 minutes. So it's useless to wait here for the 10 minutes. For the next video I will just show you the same, this training, what I have just get the accuracy and what I have just get the loss for this. Okay, and the graph of this. So in the next video will be the continuous of this video. In that we will use the test data that already have been here. We are just using the test data, and we will use this test data to use the model we already has been trained and predict this thing in the real world example. Okay, so that's all for this video. Hope so. If you like our video, please subscribe our channel. Thank you.